This question's for Nori. So she wanted to see the heck mechanism, I guess my ligand, how I wrote my ligands, or maybe that was the R groups. It was the R groups. My R groups were confusing. So basically the thing here that I was trying to stress, the thing that I'm trying to stress here is that the thing that's really cool about this mechanism is that palladium, notice how we have here basically two sp3 carbons. And so they're in an eclipsed format, right? They're these sawhorse, it's that sawhorse type structure, and they're eclipsed. And what happens, if you think, and by eclipsed, I mean that R1 and that palladium, right? It's eclipsed. They rotate, and it rotates around this bond here. So this bond rotates, and when it rotates to that more favorable conformation, so this H should be coming out. I tried to like scribble over it so it looked like out, but might be look a little dashy there. But anyways, that H is coming out the same as the R. In this case, that H is up, and so that H is now eclipsed, if you will, with the palladium. But what happens is this palladium is going to pull that hydride off. So this hydride here, this whole hydride, this whole bond, this proton and its two electrons there, are going to become a ligand on the palladium. And so for this to happen, this bond here has to rotate so that the hydride can be in the correct position to be abstracted by the palladium and become a ligand on the palladium. So you'd imagine now if you pulled a hydride off this bond, you get this double bond. The palladium's going to leave and that hydride's going to leave, and you get a double bond out of that, right? The palladium's taking its electrons with it, the hydride's taking its electron with it, and you're going to go from an sp3 carbon here and here to two sp2 carbons. And so that's how that's happening.